So let me continue with the next one. Again, I already give you the example of this. So this vector OA, or we can also name it as A. This is called a position vector. Position vector. The meaning of position vector is like it tells you the position of the final. Let me give you another color. The final location with respect to the initial location. So like if we talk about AB, for example, this is a position vector of B in regards or relative to A. So position vector of B relative to A. So then if we have PQ, then you can tell a Q relative to P. So these are called position vectors, and the way we represent. So it's still connected with the previous video, but let me erase this because this is not then the focus of this video. So if then we are looking over this vector, so then you can see that this vector OA or vector A is having a 3, 2 vector. So let's see about this vector itself. Well, what are the things that we can tell? So first about the size, or in the mathematical terms they use the term magnitude, or like the distance or the length of the line or the vectors. So now if you see that, like in the last video, then we can actually make it this way. So we can draw an imaginary right angle triangle like this, and then we can see, oh, it's a right angle triangle. It's a right angle triangle, right? So then in the right angle triangle, we know that the most famous method or theory that we know is about Pythagoras. So then finding the magnitude of, let's say in the case of this is the OA, and then the way we represent magnitude is using the absolute value, is equals to the Pythagoras, which is in the case of this it will be 3 squared plus 2 squared. So then we got the root of 13. I'll give you another example. If let's say we have let's say the bigger one like this. Let's say this is PQ. So then you see 1, 2, 3, 1, 2, 3, 4. So then the vector PQ itself is actually a 3, 4, 3 to the right and 4 up. So then the magnitude of PQ will be 3 squared plus 4 squared, exactly just like Pythagoras theorem. So it's a 5 units. So then with that idea in mind, it's including negative also actually. So I'll just give you one more example. How if we have like this? So let's say this vector is Mn. So this vector Mn is named negative 2, 1. So the magnitude will be 4 plus 1. So just squared and then root of 5. So it's kind of like this. So this is the meaning of magnitude. So then in that sense, so we can generalize. That's the idea always in maths. Maths is also always about generalizing. So in general, formula, if we are having let's say we name it AB. We have a vector AB, and then the vector itself is like, let's say, containing of AB, whatever the value of A and B. It could be any numbers. The magnitude of AB is just square root A squared plus B squared. The reason is because the Pythagoras theorem that we just discussed.